Hi, I'm Pete Shursby and this is Make or Repair, and today I'm going to look at these power meters. So these are 3 cheap domestic power meters available everywhere, and something you might be thinking of getting because of, current electricity costs. And I will kind of think a little bit about whether it's worth the trouble or not. And although these certainly will educate you about the costs of your electricity, does it help you make any actual money saving decisions? It's entirely up to you how you use these. But I have already reviewed this one. So about 2 years ago, I think it was video number 3, I did a review and teardown of this. And from the comments, some people didn't really agree with what I was saying. So one of the findings was that I plugged in a battery charger for a phone charger, and ran it on standby because I was interested in those devices. I've got a lot of things like that in the house, and phone chargers, toothbrush chargers, shaver chargers, all sorts of things, and they often stay plugged in when they shouldn't do, and I kind of wondered how much it was costing me. My finding was I had no idea beforehand, and I had no idea after I plugged them in here either. It was incapable of measuring them. Now what I perhaps could do is get a big gang of say 10 and plug them all in together, and then plug that in here and measure 10 of them and see what happens with that. But measure everything I've got in the house, in other words, all at once, and that might give me some information. But short of that, it wasn't very helpful. On the other hand, for things like lamps and things, it was absolutely fine. Now, I got a lot of comments from people saying, well, who would want to measure their standby currents and things like that, standby wattage and things? That's pointless. You use these for things like vacuum cleaners and ovens and well, maybe you do, but I also got lots of things from other people saying thank you so much for doing that, because I was going to get this because I was interested in things like my phone chargers, and now I won't bother. So always keen to help, but yeah, people have different usages and things like that, and I will try and remember that as I talk about this. But in truth, on this channel I tend to talk about my experiences and what's going on in my life, and you take from that what you want. But I do have a couple of years experience using this one now, so my views have changed slightly on it, not a lot. This one as well I've used a few times. I've used it in the lab a few times, I think on the coffee machine one, for example, and that's because I just wanted a quick look at the current and the wattage that my coffee machine was doing when I was doing repair on it. And compared to getting this beast out, this is my lab power meter. This was kind of rather convenient at the time, and yeah, it served a perfectly useful function in there. This one I got because it is supposedly intelligent, and one of the key features for me is this has dual tariff. My electricity changes tariff during the day, so this one will record how much electricity a device uses, and you can tell it how much you pay for your electricity, but only one value, one tariff. Same with this one tariff, 2 tariffs. So from that point of view, but the truth is, finding the instruction books, trying to figure my way through programming these damn things with tariffs and things, I just can't be bothered. I just measure the kilowatt hours now. But maybe for you want to put your tariff in. Now these two have built-in batteries. Now this one's battery is soldered to the board, so you cannot change it. So they've viewed this as disposable. I don't like that. If you've watched any other stuff on this channel, I'm not into disposing of electronics that work. This one here, they didn't even bother to fit. It has on the board a place for a battery to go. They didn't even bother to fit it. But again, you would have to take it apart to change the battery. Now these screws, so it just unscrews, and then it's got some clips. Not too bad to unclip, but they are security screws. So unless you have an appropriate set, you are not going to be able to get that open. This one also uses security screws, but it has a battery compartment on the back which uses normal little Phillips screws. So you'll be able to just change the battery in that. So from that point of view, this one wins. So for example, I can press the button and it turns on now, and it has its display. And the other thing this does is it measures over time, so it will look at the last week's electricity usage for your device and display it. So when I'm doing this, by the way, I haven't kind of done it in advance. I kind of just sort of commenting as I see or don't see things. So this is this guy. There's not much going on in here. So we've got our neutral. This is just passing straight through, of course. This is just a metal sleeve that goes all the way down from this end to that end. Whereas the positive, of course, is split because that's where it's measuring the current. So it comes in on, let me find something to point with. There we go. So it comes in on this wire here, this brown wire on the left hand side, goes up to here, through this, which is the current shunt, which is where we make our measurement. That's got a slot underneath it just for isolation, and then back out again through this way. So we're measuring the current literally just across this device here, and then we've got some resistors and capacitors and stuff which are going to be providing the power supply. Okay, so having had a look at the fact that the socket is fairly simple, it's just some sleeves and the power comes onto this board and off again, we'll just take a look at the underside of that very simple board that just had a couple of capacitors and things on it. And here it is. So just here is where that current shunt was that we're going to measure across, and we can see one measurement line coming out here, another one just here, and another one coming off just here. And down on this side we can see some power supply stuff. There is a Zener diode on there and a couple of other things just to build the internal power supply, and there's a couple of other bits and pieces, but generally speaking what we've got here is a current shunt and its inputs are coming along, and you can kind of see that it's actually coming just here. And if we look at the other side, we've got an input just here to this IC and an input just here, which I can't quite work out whether it's that pin or that pin. And then this part here just buggers off all down here. There's a resistive chain just here, which is all going to be in the power supply section. So this IC at the top here, if I zoom into that for you, hopefully you might be able to see it better. This is the one that's doing all the work, and it is a BL6523GX. Now, getting the datasheet for that in English is a little tricky, but I have persevered. And here it is. And so it's from Shanghai Belling, and it is a single-phase multifunction energy meter IC. So it's a custom-built chip for this one job. And it's got high accuracy, less than 0.1% error. Now, when we measure that, we will see that actually we don't really achieve that, but that's not necessarily the chip, that's to do with all the components and the entire system design. And it can measure all sorts of stuff. Line voltage, current, active power, apparent power, power factor, line frequency. It detects sag over voltage over current, peak and reverse power, zero crossing voltage, and clearly they're not providing all of that information on the display to us. And it has a 25 milliwatt power supply is all it requires. Now I will actually measure the amount of power that all of these devices take, just to see how efficient they are. But since this is basically built around, from the earlier picture, it's built around some capacitors forming a divider, and down here we've got a resistor and a Zener. This is the resistor across here, by the way, going off to the neutral. Yeah, I'm not really expecting it to be very efficient. So we've got the block diagram. This is in English. I will put the link in for you just to make life nice and easy, and you can take a look for yourself. But essentially we throw in our current, and it does a bunch of maths in its signal processor, and it provides all of the data on a UART so that any associated chip can read it. So that's what's hidden on the back of this board just here. So this deceptively simple thing has actually got most of the processing power on it, And if we take a look at this board just here, which I thought probably just contained a display driver, I suspect actually under there is a bit of microprocessing going on as well, just to do the conversions so that we can actually put them on the display, but not very much at all. And now let's take a look at the Keto Tech, which is a little stubby one. So here we go. So almost identical. And in actual fact, it's just a different version. It's JKPM01A version 2.1, and yeah, it's just a different version of the one that you just looked at already. So the X cap, a slightly different value for the 100 ohm in this case for the capacitor that goes with the Zener diode, and a couple of capacitors. Well, at the top we've got the coin cell holder. So let's take a look at the other board in here. So the second board, this is below the LCD. So this chip here does have a number, but it's not visible in this photograph, but the number is completely useless. It's just a sequence of digits that reveals nothing about it whatsoever. So anyway, not to worry about this. This one is unmarked at the top, but clearly this is a microprocessor U2 just here, one microprocessor, and probably, I was going to say it might well be doing some of the work of that power calculation, but it probably isn't. It's probably just a plain microcontroller, and up here we've got the display driver. So this is the business end. So this is underneath those little capacitors, and it's a very different board than we saw on the first one. Essentially all the processing power is being moved off onto the LCD, and this is only doing power detection as far as I can see, and I'm hoping that I'm going to be able to find this IC just here. Okay, so rather to my surprise, I have found it. Here it is, the V924X multifunction ultra low power single phase measurement IC with baud rate and stuff like that. So it's doing pretty much what the IC is that we saw in the other one, perhaps a little bit less featured. It's got a dynamic range of 5,000 to 1. The one that we looked at in the other meter was 6,000 to 1, so we might expect a little bit better precision from that first meter that we've looked at. But basically it does all the same stuff: instantaneous and average currents and voltages in RMS, and reactive power and average power and frequencies and phases, and all the stuff we would expect from a power measurement IC, and a typical accuracy of 0.1% again, just in a 8-pin package this time, but it's shoving its data out on a serial port across to another microprocessor to have a look at. And if we just go back to this, so that feeds off through a little ribbon cable, and here's our microprocessor as we expected. The microprocessor outputs on 2 lines, not those two, on 2 lines on this side, going up to the display here. So it's got some serial input, UART input going into the processor, then the processor just makes it look pretty and sends it to the CRT, to the LCD display. Okay, let's have a look at the third one then. So the third one is the intelligent one, and anyone want to guess what that looks like on the inside? It looks absolutely identical, just here. And the reason it looks absolutely identical is because it is absolutely identical. It is the same part number, just there, JKPM01A V2.1. It is the same part, and instead of having the coin cell holder fitted just here, it's got 2 wires going off to an external coin cell. Now take a look at the soldering there. Talk about putting your solder on the plastic instead of on the solder joint. Still, there we go. All of them, by the way, have had exactly the same socket. I mean, I think out of the same factory, completely identical in every way, and the way that it's joined on, these are all kind of brazed or welded joints, I think. Let's take a look at this one's second board then, because it's exactly the same on the other side. Well, I won't cheat. I will show you the other side of this board just to prove that it is exactly the same. Oops, not like that. Okay, and there it is, V9240. There's your IC up to there, and the rest is just the same. It's the same board. What else can you say? So the inherent accuracy and everything about these two meters is going to be the same. What about the processor then? Does this one give us any clues as to what that strangely marked microprocessor might be? Let's have a little look. And there we go. Okay, so here it is, and this one does have proper writing on. So same sort of LCD driver here, a few components dotted around, but they're just resistors, capacitors, nothing of any interest. Can I rotate this view? Let's see if we can't read this. Okay, so I found it. It is an HT66F3195, and as we can see, it's flash microcontroller with EEPROM, and yeah, fairly standard in the world of microcontrollers. We've got all the normal interrupts and 4 ports, UARTs. Let's zoom in a bit closer. There we go. So UARTs, timers, I/O. Analog to digital converters, and some comparators and some LCD driver stuff as well. So exactly what you need for a application like this. So I suspect the one that we couldn't identify in the previous was probably something of a similar ilk. Maybe not this exact device, but something similar. So there we go, 66F3195 is the part number. And not a lot else on these boards. In terms of the cases and things like that, they're all much of a muchness. They're similar thickness, similar flexibility, fairly sturdy for the job. No real problems. I suppose before I move on too far, I should just talk about the functionality of these. So they all measure watts, as you would expect, and they all measure it to 1 decimal place. So it'll measure, 1000.2 watts or whatever. They're all the same. They also measure current. Now, for most people, current is kind of not that intuitive. We pay in kilowatt hours. They all measure kilowatt hours. But current is actually slightly useful for the lower power things. It gives you a feel if you want to compare 2 or 3 chargers or whatever. Which I've got 10 phone chargers. Which one shall I use? Well, I'll use the one that's most efficient. Thank you very much. That does the job for me. Perhaps that's the answer. Maybe it isn't. Anyway, so current, since you can't measure wattage on these for low power things, current might be your answer. They all measure voltage. I don't see the point in that, unless I'm in the UK. 240 volts ish is what I expect to be coming out of my sockets. Whether that's 230 or 250, yeah, whatever. If it's 260, I'd get worried and contact my utility company. But other than that, the voltage is neither here nor there. It varies a bit over time, so there you go. That's what happens. And truthfully, if you plug in a big load, it will drag the voltage down because it will lose power over your actual cables in your house and things like that. So it will look like it has a lower voltage. That doesn't mean your utility power has gone down. Just that by the time it reaches your heater or whatever, it's lost a bit. Okay, what else? They all measure time. So if you measure kilowatt hours, which is what you pay for, so you plug something in and it measures 4 kilowatt hours and you pay 25p, so that's £1. And it can do that calculation for you. That's all lovely. They can all do that. However, if you want to know how much it uses per year, you need to kind of know how much time you measured that over. So how long the device has been plugged in. And you need to, and sometimes it's very helpful to know how long that device has actually been operating, because things like heaters, they turn themselves on and off. So all of these measure the amount of time the device was turned on. They do not measure how long it was plugged in. So if you run it for a week, you could come back to this and it says it's been on for 2 hours. Now, that's sort of all right. It's useful to know. Can be useful to know that your device is switching on and off. When I was testing a freezer with this, it was useful to know it was running almost all the time, and it shouldn't have been. It should have been just running very occasionally for a short period to keep frozen. So that was a useful piece of information. However, if you want the cost of something over, let's say, a week, and you plug it in for a day, you manually yourself have to make a note of when you plugged it in and when you unplugged it, because it will not do that for you. Now, this one could sort of do it by cheating. This has got a real-time clock, so you could set the clock to nothing, and it will, and just look at what, Monday, nothing, and it will just keep track of what time of day it is. So if it's for less than a day, you could cheat and you could get the elapsed time on this one. But these, they don't do it at all. So any particular exciting differences? This one has bar charts, dual tariff. You can program in things like the amount of carbon dioxide produced per kilowatt hour. But truthfully, most of these things are just novelty. And they're not really that much use. Even if you do the carbon dioxide per hour, it doesn't mean anything. Because how much carbon dioxide do you produce per hour? Well, since the UK uses a mix of fossil fuel and renewables, you have no idea. And even if you were 100% renewables, you would have no idea how your utility company accounts for the infrastructural cost in carbon of running those devices. You know what? It costs carbon to get repair people in and out. The carbon fibre that it's made from costs carbon dioxide to make, and so on and so on and so on. So, interesting, indicative, sort of, useful in decision making? No. But they have various features, and some are marketing more than anything else. So I'm going to measure a couple of things using this piece of lab equipment, and then I'll do the same measurement again on the 3 power meters, just to see how they compare and how they deal with things. First up, I'm going to do this little power block, and this is quite a low power device, and this is really just to see how they behave at the low end. After that, I'll do an electric heater to see how they handle big power. So we're 241 volts. This is kind of irrelevant because this is just what's coming through the mains. We've got 22.9 milliamps. So 22.9 milliamps is what this is drawing. And 1.41 watts is how much it's drawing. Now I could make this do watt hours, but essentially if I run this constantly for an hour, it will be 1.415 watt hours. So yeah, it's just watts over time. Now it's got a power factor on here as well, and the only reason I put that on is because these things keep going on about power factor. Now in the industrial setting, power factor matters. In a domestic setting, for the price of electricity, it doesn't matter at all. However, good power factor would mean a more efficient national grid in your country, so that you would be able to kind of move electricity around more efficiently. That's kind of its only impact. But truthfully, the domestic use of these kind of all, this is it. So this one is showing a power factor of plus 2.55 lag, and if I plug in something else, it will show point something lead, and so on, and they're all going to kind of cancel out a little bit. So yeah, unless you're interested in those points of view from designing equipment, yeah, it's kind of not totally helpful for you. You want true wattage, true RMS amps, true RMS volts, and yeah, true wattage. That's it. So not apparent wattage, not VA, but actual watts, because that is what you pay for. So that's what I've got displayed on here. Anyway, 1.41 watts and 0.256 lag on the power factor. So 241 volts. No, 242 volts, really. I'm just going to round that off. 241.88, 242, thereabouts. Okay, now I'm going to ignore that now. In fact, I'm going to turn it off so we don't have that fan noise anymore. And I'm going to plug this in instead. Let me plug this one in first. Plug this one in first and see what that says. Ooh. So you plug it in, it comes to life. And somewhere I've got a reset pin. There we go. just so that everything is reset and ready to go. I'll plug it in, get that out of the way. Okay, so there we go. So it's showing that it's running, and it's been running for 30 seconds, and it's using 1.4 watts. So 1.4 isn't bad compared to the 1.41 that we saw on the other one. We can see the watt symbol here, and we can see that, well, probably not to see terribly easy, we can kind of get at these buttons okay, despite the fact that we've got a big power block in there. At the moment it's showing a cost of 0, and that's because I just haven't programmed the cost in. Okay, let's change function. We see it switches to kilowatt hours and how long it's measured that across. And day 0. 0 days, 1 minute, 20 odd seconds. And it hasn't managed to accumulate a reading at all. Now, interestingly, the kilowatt hours, 0.000. So that's 3 decimal places. Whereas if I go back to the wattage, it's only 1 decimal place. So, interesting. Okay, so there's watts, there's kilowatt hours. Here's voltage, 242.8. So it's measuring about a volt high, but at 200 odd volts, a volt high is nothing. It's irrelevant. And it's measuring 50 hertz down here. Again, hard to see because of the wire in the way. But I didn't have a charger that the wire was out of the way of this sort of ilk. Function again, and now it's going to measure the current, 0.023 amps. So the correct version was 22.9 and this one's 23, so pretty good. I can't argue with that. That's all absolutely lovely. Now this digit here, it's a rounding digit, so it could be a bit high, a bit low, whatever. The problem is, of course, with not having another digit after it, if this changes by 1, then that's a 5% change to the overall reading. So it's not all that useful because, you want your digits to be over on the left-hand side, not the right-hand side, really, if you want to be able to make comparisons between things. But there we go. That's just lab usage stuff to think about. Let's turn it off, plug another one in. Okay, here's the pricey one, and as you can see, I can't get at the buttons to operate them, so that's not great. So I'm going to use this little thing, and I'm going to press the volts amps one, and that's measuring 243.3 volts, 243.3, so not a million miles off again, not that worried. 0.22 amps, don't know if you can see that there, 0.022. The correct was 22.9 and this is 22, so it's about 1 out, which is about 5%. But like I say, it's only the last digit. It's kind of irrelevant. You just can't rely on that to mean anything at all. Let me find another button here. So let's press watts. So watts displays watts as 0.9. Now 0.9 is quite a lot low, because the correct reading was 1.41. So 0.9 is significantly low on this device just here. Not great. It's also got VA on there, which is 5.3. So that's just the math of the voltage times the current. And then the power factor changes that for the wattage. But I'm guessing hertz and power factor go together. So here's our 50 hertz and a power factor of 0.16. But the correct power factor is 0.25. So the correct power factor is 0.25 and this is 0.16. Which kind of explains perhaps why, depending how it does its maths, might well explain why its why its wattage is showing so low compared to the correct value. And onto our so-called intelligent one. Right, here we go. So here's the live reading. of 0.9 watts. Now it's also showing things to do with on the second line, independently choosable to do with costs and things. But so 0.9, the same as one of the others, 242.8. So pretty good on the voltage. 50 hertz, yeah, well there's a surprise. 0.022 amp. So 22 milliamp. And the right reading is 22.9. So again, just one digit, really, nothing to write home about. So they all seem to be measuring the current pretty well. The power factor on this one is 0.13, which is the worst of the lot. So at these low currents, it is much more difficult to measure these things accurately. Let's plug in then something with a bit more juice. Hopefully that helps. So I've plugged in a heavy load now. I mean, see the voltage has actually dropped a little bit, 238.4. So literally that's just the losses in the cable because we've got a heavy load. And it is drawing 9.395, 9.4 amps. So not milliamps anymore, we're right up in the top here, amps. And 2.223 kilowatts. Now I said the label said this is 2.2 kilowatts. So yeah, that's okay. The power factor 0.9946 lead. So this is a fan heater. So most of that load, almost all of that load, relates to the heating element, which is resistive in nature. So that'll be power factor of 1, which is perfect. And it's also got a fan, which is inductive. So that's creating a little lead of a very, very tiny proportion. Okay, in the previous section I thought it might be helpful for you to see me kind of operating the meters and kind of see what issues that brought and how it displayed information. But for this section I'm going to kind of shortcut that and just showing the results in this grid at the top. Now what I've done here is highlighted the kind of worst results in sort of a pinky reddy colour and the really good results in a green colour. So if we look at the low power first, the basic meter actually performed very well right the way throughout. So it was the only meter that read the low wattage well. And if you remember what I said, the one that really matters is that wattage column, because from that will be calculated the actual electricity usage and everything else. So 1.42 real value, 1.4 measured by that, which is as good as it can get. And if you saw the section on the teardown, you might be right in suspecting that it's to do with the dynamic range. The chip in this meter has a significantly greater dynamic range than the one in the other two. So the basic meter had a 6001 dynamic range and the other two meters a 5001, and that does make a difference, particularly when you're trying to pull out those low numbers. Now the worst error on the power was 37% at that low end, and that was on both the Ketatech and the intelligent meter. And in all of them they did a really crap job on the power factor. Looking at the high power device, they were all pretty good. So the basic meter was pretty much spot on, no problem there at all. The Ketatech was pretty much spot on as well, and the intelligent meter was a little bit low. How much low? 1.2% on the current and 1.3% on the power. So I think it's just measuring its current, just a shade on the light side. But 1.2 and 1.3% are neither here nor there when you're talking about kilowatt size machines. So there we go. So overall, these are kind of fairly useful. They measure pretty well. The basic meter, funnily enough, seems to be the best if you want to go for the sort of lower current measurements. But how well that stacks up between models, I could buy another one and it could be absolutely terrible. So, you take your pick. For me, I would still, despite the fact that the readings are so bad, I would still go with the intelligent one because of that replaceable battery, because of the dual tariff capability, and that sort of stuff. That adds up a bit more for me, I think, on balance, and I'm not expecting these to be lab grade equipment. The Ketatech was really annoying, didn't have the battery in, and that actually makes it more difficult to use. You can't take a measurement in an awkward place, unplug it and then go and review the measurement later because it forgets it. The basic meter, pretty good, but you need a soldering iron if you want to change the battery. You pay your money, You take your pick and hope for the best, really. But I would still have to ask what most people are using these for. Yes, you can measure the voltage. Yes, you can measure the watts. Yes, you can measure the kilowatt hours. And that's nice. And it informs you, perhaps. Does it help you make decisions about what you're going to buy next? Not really, because what you're going to do is you're going to look at the retailer. You're going to look at the efficiency labels if you're interested in that. And you're going to buy what you want. So, yeah, I think it is of some use. It is of some educational value. But in the decision making for buying expensive electrical equipment, it could even actually encourage you to buy things when you don't need to. But they do the job that's advertised. They do it pretty well. And, I'm happy enough to have them in my lab. Would I buy them again? I probably wouldn't buy that Ketatech. I think it's overpriced. I've put links in to everything down below, and knock yourself out. I'll see you next time. Take care in the meantime. Bye for now.